To add a little bit of variety to the motion of the particles, we'll bring in a node that turbulizes the particle velocity over time. If we look under our particle modifiers, we should be able to find the turbulized particle velocity compound near the bottom. If I drop it in, it's an execute type, and we could either choose to execute particle velocity per frame or at the initial emission point. And what I'm going to do in this case is plug the turbulized particle velocity into execute on emit 2. Now in this case, it doesn't really look like it does a whole heck of a lot, and I'll show you just the difference in a moment. If I was to plug this into the execute on port 1, we get the particles compounding over time, their values adding to each other and turbulizing over each frame passing. In our case here, we just want to do this on emission. We want to randomize the turbulence at emission time. So the way to actually get this to work, to add a bit of a subtle upwards motion to the particles, is to double-click on the compound. First of all, make sure that the effect is an animated effect, so the effect can be seen over time. And if we change or vary the animation speed with which the turbulence moves through the particle velocity, this will help us to kind of achieve the effect we're looking for. So you can see that there's a little bit of side-to-side motion, but the particles are more or less trending upwards. If I lower the overall strength, we can make the effect appear a lot more subtle as well. Also, by increasing the turbulence scale, we can see the particles will tend to follow each other a little more, but in this case I'm going to keep a fairly low turbulence scale, just so the particles are moving side to side. They are having some lateral motion, but they're still creating a smoke-like pattern nonetheless. You'll notice another thing that we can do is provide an emission direction for the particles. We might not want them to emit upwards or along the particle's local y-axis. On the emit from null compound, we have a choice of using an input direction that we provide, such as another object, or we can use a particular axis. So if I was to use something like an input direction, I could use another object, like a null. Just switch it to the little pyramid shape. There we go. I could use it to point towards this positional vector. So this would give me a way of having the steam emit from the side rather than up into the geometric object here. So it doesn't really art direct as well. If I pull in the global position for that null, I can plug it into the direction and have the particles follow that initial direction. So that's kind of cool too. We get steam sort of emitting from the side of the mech. I would also want this to follow the character, so it would be important to either pose constrain it to its emitter object. So in this case, this would be the left direction for steam. Whoa, that scared me a little bit there. 5 buttons for hotkeys in Windows. Don't do that too much. Left direction for steam, so this would be a constraint. And if I do need to slow the effect down somewhat, I could add a little bit of drag to the effect as well. The particles might be moving a little too freely at this point, kind of getting a little too far from where I intended. So I'll add a little bit of a drag force to them by accessing the particle tasks, moving down into the add forces compound, dragging it in, as well as a drag force, and we'll execute that into port 2 of our ice tree. So the particles won't really go anywhere now. They'll be severely restricted by the drag, but if I lower the drag strength, we'll get the particles out to where they originally were. So it's just a matter here now of working this drag strength and finding an appropriate value. I do want the particles to kind of die off right around this emission null, so this actually looks pretty decent here. And again, increase the strength of the turbulence or the scale, just to get some more random motion to the particles. Okay, so the last part of this is getting an appropriate size and shape. If I double-click on the emission compound, once again, I'll initialize the shape type to spherical, and then increase the size so that the particles have some form of overlap. The more overlap they have, the easier it'll be to render using the volume shaders. Okay, maybe I'll take this emitter object, or this direction object, and I'll move it downwards a bit more. Okay, so that's looking like some good slow-moving steam. If I want the particles to die out, but not do so based on their age, I can actually control the colors, the particle alpha, by using a set particle color compound and modifying the alpha based on the particle age, or the age percentage. So let's do that and get the particles looking a little nicer in terms of color. So I'll give them a gray color before I move into the render tree. So if we look at set particle color, I'll plug it in after the initial emission, and I'll take the get particle color compound, and I'll output its RGB color, RGBA color, and we'll convert it to a scalar. So we'll say RGB to color, or sorry, color to RGBA. So we end up with 4 separate scalars, red, green, blue, and our alpha. And then I'll convert my color back to RGBA, or sorry, RGBA back to color. But to build the appropriate stream for the alpha channel, I'll get the particle age percentage. There we go. Which is a scalar value, and I'll use that to drive the alpha channel. So if I actually just show values, we can see that we're returning values from 0 to 1. So if I turn this off, you can see that the particles are actually starting off very faint and becoming more opaque as they move through their life. So we need to invert that, where the particles have full alpha at the beginning of their life and 0 at the end. So we just need to rescale the effect coming out of the age percentage output. So I'll rescale that and invert the values. So the start and end 0 to 1 will become a start of 1 and end of 0, and we'll clamp that down. So the particles come out totally opaque, and before they die out, they move into a transparent stage. As far as the color goes, I could simply just set the color through my initial color port, my initialized color port, because I am getting the particle color at initialization and recombining it and connecting it in my ice tree. So I'll actually plug a randomized particle color compound into my color input on the emit from null. So let's look up a randomized compound and randomize by gradient. There we go. We'll double click on the gradient, and I'll pick a colors from medium gray to I guess a white, and I'll plug in like so. So if I hit play, we get colors that resemble our particle stream, much closer now. Alright, so I guess a couple more things I could do before we begin the shading are controlling the size. So if my size is 0.34, I'll randomize around that. Randomize value by range, and so 0.34. Let's go with 0.2 and 0.5. So there's some larger and some smaller particles. Oops, I plugged that into the rate. Not very helpful. Okay, it looks like the alpha of this mounted line is kind of blocking my particles here. Yeah, I think that'll look pretty good. Okay, so let's move on.